Okay, now that we got those digestive neurons powered up, that must be consuming sugar from the moon.
Yes.
That was composed of 8%.
80% of your sugar is
Artifacts.
I pity the poor person, whoever listens to this thing. Listen to that idiot talk. Not you.
No, that one. Direct your attention to that one.
Okay, so some of the things that we had talked about earlier, some of the unwritten things that you don't see. Aromatic hydrocarbons, what might that be? Ring structures and benzene, that's right. So if those are the aromatics, who are the aliphatics then? Yep, and that could be any one of these. Although these can also form in ring structures. We've got benzoic acid, we've got phenol, and these can attach to, especially amines, ketones. I'm not quite sure on that, but yes, those can form in aromatic compounds as well. And another aspect that we had mentioned is what is a carbonyl atom or carbonyl carbon. It's got something specifically bonded to it. Not just another carbon, not a hydrogen, but something more specific. Well, we're going to hit ourselves over the head if I just tell you the answer. No. But you're right, but in an incorrect way. Means it has a double bond oxygen on it.
Oh,
Which
yeah.
is what you were trying to say. That's why I said you can hit yourself.
You gave me the look like that ain't right.
You like ox.
Yeah, but you were looking at me like, ooh, that's wrong. So I retract it.
No, I just do things that former students really don't like it. When I do. Sure.
Yeah, I really
Are you
do.
sure? Okay. But the reason I say a double bond and or oxygen and single bond, there you're referring to an ester, and we at this point we're just more concerned about just the double bond of oxygen. So specifically, is it? Yes, but in an indirect way. Let's go in a specific order. That would make sense. Okay. So of these, okay, so we will go ahead and set the esters aside. I don't have it up on that right there. So throw that aside. There are 1, 2, and aldehyde should be up there. And so of what's remaining, if aldehydes was up here, how many carbonyl carbons would we have? So throw that one aside.
Okay, so
Ketone is 1. Oh, we haven't discussed these yet, have we? So how would you know? That's why. Okay. Yeah, ketones is, that's correct. Okay? So we'll come back and cover these. And a molecular formula, as you can see, is if we have C8H18. Okay? That meaning octane. You're just given the atoms, the number that are present, and no other bit of information, which is different to me. You have the space. Sometimes always go by the structural formula, especially when we start going through the aromatic reactions. Because when you start putting halogen derivatives on there and how they attach, when you try to do the molecular formula, it gets to be a little too confusing. Students tend to lose track of that. So with the structural formula, you're more than likely going to be right, be correct. So there's nothing wrong with always using the structural formula. And now down the road, when one of you is taking this in college, I'm presuming just one of you three, maybe more. I find it hard pressed that it would. I mean, it's possible. You do need to have 8 credits of science for a bachelor's degree, regardless. But I don't think you'd be pounding on the door. Let me take the organic chemistry class, please, please, please.
I just think like less than I think. Just like
Good. So yes, they all would work. All right. So where does that put us next? Okay. So let's just go ahead and go through this. One of the things that we try to do is, as we're going through these terms, apply them to the compounds that would fulfill that definition. Now, of these, what's most easily relatable to what it is that we may possibly be doing is, of course, the alkanes. Alkenes is something that we can't live without. That's certainly true. And the reason I say that is, yes, this is paper, but what's it surrounded by? Well, it's laminated, but that laminate is plastic, and which would have a common name of not just ethene, but polyethylene. Okay, so then if we're talking about polyethylene, what type of group would you suppose we're talking about? Yeah, alkene. So plastic is a double bonded carbon, and that's a repeating unit, because that's why we call it polyethylene. It's a whole bunch of monomers linked together to make that polymer. Okay, so let's go ahead and I think we can shut this overhead down. We want to go through some examples. Then we'll break it on down.
Yeah, prepare yourself for this choreography.
You go to strong man, running man, sprinkler.
I like your running man personally. You want to demonstrate?
Oh, I have to dab again.
Oh! Oh! Yeah. How does that? Go and follow, please.
So who's in charge? No one wants to take charge.
Single one of them out.
I thought I said it. Maybe
The truck roll. Just shout it.
Chase them down.
Yeah. Yell it, run.
too late.
Chase after them. You could be them.
But it didn't say something in a row. It's just my mic. So that's why I shut it off. Okay. So as we go ahead and continue forward, as we had stated, molecular formulas, structural formulas, one of the things that we need to write down, and I think with just a little bit of review, we wouldn't even have to go through all 10. You would probably remember all 10. What I mean is if we started off with this.
Name them off or?
Okay, so one of those three. So
Ethane, propane.
propane, and then we should have done one more.
Butane.
Yep.
Wait, what's the first? It's methyl alcohol.
No.
Methane.
Okay, so once you get past number 4, and then you get to C5H12, okay, it is because then your hydrocarbons take the name of that geometrical shape. There's 5 carbons, it would be pentane. Hexane, and 7 is heptane, yep. Octane, nonane, and decane. That's right. So these are your molecular formulas. Okay. So what's much easier to associate that with is perhaps this, the molecular formula. And you could go on so on and so forth. Okay. Notice that each carbon wants 4 bonds. Okay. So that's certainly present in those 2 compounds that we have written up to this point. Okay. So when we say, for instance, element number 80, so you pick 82 or 26 or, okay, so element 26 is what? Okay, so if that is iron, why does it not have the symbol I?
Because it's the Latin name, some other name, some of
Yeah.
it. What is this?
It's ferrous is Latin.
Oh, so I was right.
Iron. You were right, that's right. So what that means is the name or element given for that is derived, in other words, comes from the Latin term. So when we get into these derivatives, okay, they are derived from the molecular formula or structural formula that they come from, the base alkene. So notice that with CH4, we know we've got methane, but this R is just a variable for any hydrocarbon. Okay? So if we take this variable and attach another carbon, okay, and then we do this, and then I guess we need to do it that way. But we say X marks the spot. Okay. So what is significant about where that X is? There's what bond is below that. It's one of the derivatives. It's a methyl group. Okay, so the term methyl, remember, is derived or comes from that of methane. That's why we call that a methyl group. I guess I don't need to use that variable up there. I'm afraid that's probably just going to confuse you. So I'll just put that back as a carbon. Okay, because each one of these carbons has hydrogen bonds. Okay, but remember where the X is, this is not a hydrogen bond. It's a carbon-to-carbon bond. So that's why that is not methane, that would be methyl group. So keep in mind that when we derive these derivatives, okay, that methane gets derived to methyl. Okay, ethane, or excuse me, ethyl is derived from ethane. Okay, so notice there's a repeating pattern that we see here. The carbons are increasing by 1, but the hydrogens are increasing by what? By 2. Then when you get to the derivative side, yes, the carbons are increasing by 1, and also the hydrogens are increasing by 2. But rather even numbers, they are what instead? They're going to be odd numbers. Okay? So as we proceed forward, this then is a propyl group. That is a butyl group. Okay? That's where what a simple list. And I laugh because we can throw a whole lot of junk out there at one point in time. Blah, just throw it all out there. Should we? Yeah. Okay, we're not going to, but I just want to show you a couple things. Okay, what I mean by that is this. Okay, so notice when we put an X here, okay, that was a carbon to carbon bond. So if we put two more, okay, now we're going to put an R here because that's going on. This is the parent chain up here, is what we're saying. It's going to be straight across. Okay. The reason I put that R is it just saves me from putting a whole bunch of carbons across the top. So what I'm saying is we know that this is a long parent chain going in this direction. So that way you're not going to get that confused and say this is a branch chain. No, it's not. So when we see this C3H7, we know that that is a propyl group. We've established that. Okay. Now that's different than an isopropyl group. Okay. Because when we're talking about an isopropyl group, these two disappear. Well, they don't disappear. We're going to stretch that out a little bit. Yeah, I suppose you could say that. Okay, and this is another aspect. You're never wrong. Well, we hope that you never be wrong. But if you always write out the structural formula, you'll be just fine. Because if we were to do something like this, rather than writing that structural formula out, okay, this could possibly confuse. I'm not saying it would, but it could. Okay.
Was that how you indicated isopropyl?
That's also an isopropyl group too.
So rather than like.
So it's the molecular formula for an isopropyl group, but sometimes that's written. It's just for that way for good practice. Okay. Because notice when we distribute that 2 through here, this is one methyl group, but when we put that 2 on the outside, now we've got 2 methyl groups there. Just like we had earlier. There was one on this side, there was one on this side, and that hydrogen was down here on the bottom. Okay? Make sense? Clear? Clear as mud? Yeah. We're chugging right along. So we got Thomas the Train here. Chug, chug.
You have to do the noises.
Choo
Do the
choo.
noises.
Choo choo.
Do the noises.
You can be progressively closer to me.
Slam on the brakes.
There it is.
Choo choo.
Yeah.
Choo choo.
They go both ways.
Yeah.
Oh, go say hi.
Yep. Okay. So the last thing that we want to go over, we're not going to try to make it go too fast. What I mean by that is, okay, 3 carbon compounds, we know, okay, we know that's an alkane. How do you know that? It's single bonded, okay, and there's only carbon and hydrogen in there, okay, so how would we change that propane to propene?
Well, you can take one of the bonds with the carbon double bond and
Okay.
carbon on
One of the bonds has to be doubled, okay, that's correct.
the end. And then you gotta take out 2 carbon. from the ones that are attached to the bond.
Okay. So when you write these, if you want the hydrogens on top and the bottom, that's fine, or on the top and the side, it doesn't make any difference. Because it's going to be the same compound. Okay. So if this is propane, this is propene, guess what would be next? Propine. And how would we make propine?
We only have one carbon attached to one.
And how's it bonded then? I wrote that incorrectly. Okay.
Oh, and then carbon on the end can't have two.
Well, which one's the end?
On the right end.
Oh.
The right.
Oh, sorry, I did it backwards. I didn't have the first carbon to triple bond, so I was looking down.
That's fine. So, can we draw an isomer of that?
Yeah.
No. Can we draw an isomer of this? No. You have, when it comes to when these are double bonded, you have to get up to at least 4 before you can make an isomer. Okay. So then from yesterday, I believe we had, for instance, wrote this one. And we're not going to name it, but what organic family is that? Is it hard to see?
Yeah. There's a glare right there.
Okay.
I got it. Okay, it's just one. So let's be a ketone. No, what?
You've got a double bonded oxygen and a single bonded oxygen on the same carbon. That is an ester. Then we went on and talked about this guy. Okay. I don't like ethyl methyl ether. I don't like it either. I don't like it either.
You don't want either. I don't want either.
Oh.
Good one. Your jokes are just too witty, Mr. Kenny.
No, you give me too much credit.
No, they're pretty good.
I'm just on the level you gotta
You'll get there. You'll get there, maybe.
Okay. Then, okay, we don't even have to erase it, everything. We can just do this and then change that to, change it to a ketone. Okay. Now, for all practical purposes, I want to do an aldehyde next.
How do you spell aldehyde?
ALDEHYDE.
Start over.
Okay.
So you add that to
So, yes. So now, that is an aldehyde.
Oh, so the it's on the end.
Yes. Aldehydes have carbonyl-carbon when it's on the end. Ketones have the carbonyl-carbon when it's somewhere other than the end.
Carbonyl. What it is?
Okay, carbonyl-carbon is this guy and that one.
Yeah, how was that one spelled as well?
What carbonyl?
Yeah, carbon EL.
I think there's a Y in there. I'd have to double check for sure.
Carbonyl.
I'll get back to
Carbonyl and
that.
YLE.
No, I know that.
That's carbonyl.
Oh, what am I saying?
You know, one of the things I thought about
It's just carbon YL.
when I was working on
Without the E.
that cell phone holder for for those of you who listen to country music, that this lyrics is perfect for sometimes how you deal with things in science. And it is, I'm trying to think of the group now. Eli Young Band. What's their latest signal? Went pretty high on the chart. Don't look. Oh, unless you need to. It's something love what?
Yeah, I have listened to a while. Loving.
Yes.
Loving.
Okay.
Oh, I know that song.
So what that, if you follow the lyrics of that song, I know what love is and I sure know what love ain't. That sound correct?
Yeah.
So sometimes that's a lot of the ways that we approach science. When you don't know what something is, you eliminate for sure what it isn't.
Fair enough.
Okay? So when you're talking about that spelling, it's kind of way you went. And you're trying that's great. But I know that it's not right.
To be fair though, I only had one letter wrong.
So
That's pretty good for me.
then finally, the last one that we will go through is going to be. I gotta go get more markers, that's for sure. Okay, ones that are about dried up, and that's this guy here. Okay.
Isn't that alcohol a double bond? Oh, and then hydrogen on the end?
No, it's OH group. That's a.
Okay.
That's it.
That's an acid. Okay. So alcohols and acids are somewhat related because they both have an OH group. Ketones and aldehydes are closely related because they have a double bond of oxygen, but it's where it's bonded that makes the difference. Okay. So the first three you would be responsible for naming, of course, the propane, propene, propine. Then the last four that we've gone through, or five actually, because I changed this one. Because this used to be an ester, now it's a ketone. These, you're just responsible for knowing the organic family. And the reason that we do it that way is because it becomes so important to know what something is when you go through the organic reaction. And that's why when we did this when you were freshmen, we just did 1 through 10 and 2 derivatives. Okay? And halogen derivatives. We haven't got that far. Then when you were general chemistry students, we did the first 10, the halogen derivatives, and then methyl, ethyl, propyl, and isopropyl. And then now we haven't done the butyl derivatives, but you need to know the organic families because that's how you navigate your way through that flow chart. All right. Left side, we're on the bus.
Yes, sir.
Right side, we're on the bus.
Yes.
I almost said train. We want to be on the
Can we be on the train?
You're on the train.
Yeah.
Wait, the naming convention of an acid would be propanoic acid.
There'll be propanoic acid, that's right. Now, that's not relevant yet, but further down the road, yes, we will go into that.
So an alcohol just has an OH tacked on the end?
Yes, or in the middle, anyway.
Oh, just an OH group?
Yes. Yep.
Propanol.
Okay, so we will pick up with this tomorrow.